So we're going to have this expectation story refreshed a little bit, just a little bit. We had a little quiz on it, so just to see how this table process was designed. So all we needed was to multiply probabilities by values that correspond to them, and that's exactly what is done here in the example to get that so-called expected value. So what you expect is always the average. So when you get this multiplied and then add it all together, you get yourself an answer which is called expected value. And that's what we had on the quiz. And I think pretty much everyone did it perfectly right. This is great. I'd like to do this example. It was here. So we just looked at one little page of that section. So I don't think I'm going to continue because you told me that this section was not planned anyways. So, well, at least we had a chance to take a look at it. So we have this corresponding outcomes multiplied by probabilities, and to get the value that was expected. So I guess that was problem 2 for a quiz, or problem 1 that we had for a quiz last Friday. So I'm gonna multiply and add these values all together, like that, and then also 3 times a quarter, and that looks like 1 3/4, right? Or 1.75 if you put this in the calculator. So that's what's expected to be on this clock. Of course, it is not possible 1 3/4 because it's either 1 or 2 or 3, but that's what you get in the long run as the average. That's the idea of expected value, which you expect when you do experiment thousands of times, and the average will be somewhere in between 1 and 2, closer to 2. Well, so this is the end of chapter 11. So I don't ask you to do problems here on this page. You can skip them. That's something that I guess we don't worry about it. And it looks like we're finally done with 11. So I hope we will enjoy 12 even more than that. So we don't need to worry about all this special review and chapter test type of problems. Just skip those, don't need them. And we're entering the chapter that is called statistics. And we'll see how we can make summary of just about anything that happens in the real life around us mathematically. So statistics deals with presenting so-called populations. So we always deal with something that is called as a population. That's a special statistical word that people, I guess, will get eventually used to. Population, that's everything. Everything means everything that you are trying to study. So for example, if you're trying to study people in the United States, well, that'd be your population. And of course, it'd be extremely difficult to get information about entire population of all people in United States because it changes, right? Some people arrive to United States, some people leave, some people born, some people die. So it's always changing. So you cannot really study every single element in your population. And that's the reason why people select a part of population called sample. So that's what we can put our hands on. the sample that we selected, and we'll be able to do all kinds of calculations related to the samples. And once you made some kind of calculational results, then you will make inferences about entire population. So that's the plan for this chapter, to learn what is going on in various populations and how to do this correctly. So we're going to look at the examples of populations and samples. And of course, we're gonna talk about very special type of sample, which is called random sample. So random sample is a definition. Please notice that this statistics science has its own vocabulary: population, sample, random sample. So those are words that we should get used to little by little. I will be repeating them, so I'm sure you will get used to understand what we're talking about here. So random sample should be selected, people say, correctly. What does that mean? Well, you are selecting sample of size n, so you decide you're going to have 10 elements or 1,000 elements of sample size. And then you need to choose the elements in such a way that each element of population will have same chance, same probability to be selected. That's the key idea. So if there is no chance that you can select some of the elements, well, that's not called random sample. So it's already not as good as if it be selected at random. Of course, there could be various reasons. Somebody can say, you know, Alex, I just went to the college and I surveyed some students, and here's my result about population of people that live in the United States. Well, first of all, the college has students that mostly live here in Florida, so your inferences will probably be related to Florida, and not even to entire state, but the South Florida. So you should be careful when you make your inferences. And that's the idea. So you can produce a perfectly correct study, but if you transfer your results to entire population of United States by selecting sample in Florida, well, then it may not be correct for people that live in Alaska or Idaho or some other state, because you don't have any representatives of those people in your study. So that's important to realize, that your sample should be random. And if you cannot select your sample out of entire population, but just from part of it, from some particular cluster, people say cluster, so you can say that's a study done about the cluster of people that live in this particular area, and that'd be more correct, because otherwise the information that one spends time producing may not really worth much, because it's not going to be applicable. So that's the reason why that random sample idea is so important, to be able to select those samples correctly, select samples correctly. And for that matter, they have various ways of doing it. But once you start to think about selecting the sample, you will notice that's not that easy to do, because to select the sample, one needs, well, to have some funds and probably to have some authority to be able to talk to every person, because once you decided to study this particular group of people, Well, some of them may just not feel like talking to you. They say, no, I don't want to give you any information. It's private. And what you're going to do about it? So you need to have some level of authority or access to people's data in order to deal with that random sample. So it is important to realize, and of course, if one works for a local government, you definitely have enough funds for this, but main reason why people that serious about their study pay to some statistics companies is simply they want to know the exact data of what is going on in this population, say before opening some new type of restaurant. Maybe you want to learn what is going on in the area first, and how would you do that? Because just asking your friends and family is not enough, because there could be people of totally different type living in this area that may be interested in that restaurant, but maybe you and your family do not really care for that. So that's the idea. So you really want to make sure that you get the random sample, not just people that convenient for you to talk to, because that's called convenience sample, and that's the worst case scenario that you can get. You really want to try to go random. So anyways, once you collect data one way or another, usually you put this data in terms of some type of numbers, and that's what they have here in the next page. They produced a bunch of numbers here, and they say that's a bunch of data items here. So that's a sample, and we can calculate how many elements in here and do various summaries based on these samples. So the idea is, once you have your sample selected, well, you collect some information, some ages like here, for example, and then you produce various groups of this data, so-called tables, like they have here, table on the left side of the page. They actually nicely summarize this sample. They broke this into various age categories. Looks like there were teenagers, and they had it, well, so from 10 to 18. So actually, well, just some young people. So 35 boys, they say. So there were various ages. And then they saw how many of boys of particular age were present in the sample, and notice that probably the most popular group was 14 years old, because there were 9 of them. The point of this is to make someone better see what is going on. So when you make a table, when you summarize your data carefully, well, then instead of looking at just bunch of numbers, so if you just show to someone these numbers and say, look at these numbers, do you see 14 is most popular? Someone may be a real puzzle saying, how do I know there's 14 is more popular? I see 14, I also see a bunch of 15s here. So you need to present this data in such a way that the other person will easily understand it in so-called intuitive way. And that's why they produce those tubular summaries, and they call them as distribution. Distribution will be a big word for us. In this chapter, we'll deal with those distributions that show us how our elements are distributed into various classes or groups. And we usually use the word classes in statistics. So it looks like they had something like 9 classes, and looks like the class with 14-year-olds was the most popular. And then we also had 13-year-olds and then 15. So it looks like this age has most of the representation in this particular table. So that's how we summarize the data, and then we can deal with those distributions, and that's what we're going to see a lot. Please notice that this distributions could be designed various ways, but in order to get to work with a sample, you always try to see what will be the largest and what will be the smallest elements of samples. So when I'm looking at this particular sample, I can see number 94 that appears here, looks like the largest, right? And the smallest number I see here is what, 54, something like that. See, it's not that easy if you have a large, no, not 54, 45, right? That's the, no, 43 even, it's even lower. See, it takes time, and that's really not as obvious if you throw a bunch of numbers at someone, and how would people right away see what the smallest is 43? You really need to look closer, right, at this data. And I guess that's the key idea why we designed this little charts, tables, or some other ways to present data, so people get some intuition into what is going on. So the next page looks like they did this summary here, and they broke this into various classes. And notice that since we had so many different ages, it wouldn't be convenient to present data the same way as we did in a previous example, where we had only 10-year-olds or only 11-year-olds. So just one data goes for one class. Now, when they produce those classes, they, for convenience, have from 40 to 49 and 50, 59 and so forth, all the way up to 99. So they break our sample into 6 non-overlapping classes. So the classes should not intersect, touch each other. They need to be separate. So every element will belong to only one class. That's very important. So you don't have element that belongs into one and to the other class at the same time. So it's not going to be a distribution. So we are producing distributions, and once you have a class, next to it, you put another statistical word. Number of elements in the class, they actually show it here. They say number of students, which is called frequency. See how frequent this class is represented in the table, frequency. That's another popular statistical word, frequency. And when you produce this table, it's going to be called frequency distribution. Shows how those little frequencies are going to be distributed in this particular sample. And once again, you can see that the most popular class usually is somewhere in the middle, although in this sample, it looks like its elements have tendency to be larger rather than smaller, because we see that 11 elements for 70 through 79, next largest classes from 80 through 89, right? So, and then we get to the smaller side. So it looks like this class is heavier on larger elements, this sample, this particular sample. So once you collected your data, you can produce tables that we call distributions, tables that put frequencies in them, called frequency distributions. And again, all that is designed for you to make someone understand what is going on intuitively. So what they did on the next page is they produce a graph they went back to the same exact table, looks like the one that they had on the beginning of this section with these boys and their ages. Remember, 14-year-olds were presented as the largest frequency. And then they put this as a bars into this bunch of bar graph that they also gave a special name. In statistics, they say it's a histogram. They say, Alex, I have to memorize all that. No, I always clarify it for you. I don't expect you to memorize it, but it's good. Eventually, I'm sure you will get familiar with histogram is, or same as a bar graph for us. So what they did here is they put our classes there on x-axis from 10 through 18, and then along y-axis they put frequencies. And notice that since the largest was 19, it is convenient to put, oh, not 19, 9. That 9 on the very top, so the graph fits nicely into this picture, and they produce these bars, which is same as if you had a table, but I'm sure that if you show this to someone, let's say you have your business plan, you go into the bank to get a business loan and you're trying to explain something to bankers, that might be a good idea to produce nice histogram so the person that is deciding whether to give you a loan or not, some investor or whoever, will understand what you're talking about, right? So if they see nice intuitive picture and you will say 14 is our target age and maybe 13 and 15 because those are most popular ages, they will definitely agree with that and understand what you're talking about. That they probably 17, 18-year-old or 10, 11 are not as often appearing in your population. So yeah, you better target those ages and then you take a loan to do whatever for this age, and that'd be probably a very good and successful idea, right? So that's worth to think about. Well, there are various ways to present your samples, and that's what they're talking about here. There's another way to present sample that actually appeared in the previous page. That sample was lowest element 43, and then there was a 45, 40, not 50, and then 47. So if you look at the first row of the table here, turns out what I'm trying to do is get the sample elements such as a 43, 45, 47 that happen to have first digit 4. And the way they put here in this special stem and leaf plot is that first digit 4 goes in so-called stem and second digit is separated in a leaf. So in a way you get bar graph also, which is turned, it's like bars that turned by 90%, 90 degrees, sorry, by 90 degrees around. So you turn it and put it on the side, this histogram that we saw in the previous page. So it's a numeric way to produce a histogram. Usually is being done by computer software, but that so-called stem and leaf display, that is also quite popular and sometimes is being utilized in the various examples, stem and leaf display. So that appears in here. So there are various other ways that people present data, but stem and leaf and histograms, bar graphs are the most popular. So I'm sure you're familiar with pictures that we see here right now. So the largest picture is usually for the tallest is for the largest and so forth. So I just started to talk about this little section. It's an introductory section. So I guess there is not much I can ask you to do here. I should do some problems myself, I guess, because for a quiz it'd be a little bit too early. And today I'd like you to fill the student evaluation, which is hopefully available on the Blackboard. For every class, I think you fill those student evaluations for every class you take in our college, pretty much for every class. So they asked me to remind you to please do this student evaluation. So I'm gonna stop today's recording